Hello and welcome back to yet another episode of Matrix Tech Talk. It has been a while and we really appreciate your support, your views, your subscription and your likes. Thank you so much for being with us. We'll bring you more and more. So today I'm super excited again because we have the guest that was with us about a year ago in our episode 3. Please welcome Rolf Jung. Rolf, welcome back to Matrix.
Thank you, Hasan, to be back.
So just for the reviewers who haven't seen episode 3, can you introduce yourself a little bit?
Yes, thank you, Hasan. I'm professor at the University of Applied Sciences in Kempten since 4 years now. My subject is functional safety, and I'm teaching in Master Studies of Automotive. That's a master course, Advanced Driver Assistance Systems, and of course the part of functional safety that deals with machines, and this is taught in a master course, Automation and Robotics. And before I had been in industry and had been dealing with functional safety for nearly 20 years.
So I will do a quick recap of what we talked about in episode 3 and we'll take it from there. In episode 3, we talked about the starting of functional safety, how functional safety got developed. You talked about how you personally got involved in functional safety. And then we also talked about the job market of functional safety. We talked about your master's program. And in the end, we also looked at the future, how the future of functional safety can develop. So we'll take it from there. Can you please tell us, within this 1 year time, from the last time we talked, what are the things that got developed? What are the changes you have seen? What went better and what could have been better?
So what we started with, of course, was functional safety, and this has been established, this subject, in industry since, I would say now, decades. What came as an additional part is that you see on this board is these two subjects, SOTIF, shortly called Safety of the Intended Functionality.
Here it is.
And Automotive Security, which of course is a subject for decades as well, but it's the IT business, the IT security. This is well known, but as a part of embedded security in, for example, automotive industry, this is, let's say, fairly new and is a big subject in the industry since the last years. So what we're doing is there are so many groups being built and set together that are dealing with the combination of functional safety of this SOTIF kind, which we'll talk about later on, and the automotive security. And this is a very big subject for the future. So we know that there were many hacks been done in the cars. That is what you described already in lots of podcasts. But the combination of functional safety and this automotive security is a matter that not many people took into account as it should have been. And there are so many cases found in meantime that there has to be lots of actions in that direction. And I've seen some groups that are working on that very eagerly.
Fascinating. So you already mentioned two very stimulating topics, SOTIF and ISO SAE 21434, which is the upcoming standard. The standard is not yet there for automotive cybersecurity engineering. Now, let's delve into it a little bit. Let's start with SOTIF. My question to you is, what is SOTIF? Why do we need SOTIF? And what is the standard? What is the status of SOTIF? And how will we apply that in our automotive safety landscape?
Maybe I start with a bit overview of what is safety then.
Absolutely, yes.
Safety, of course. you need to be aware that we have hazards, and hazards in automotive industry is clear to everyone. And you need to take care of all processes and subjects, equipment, combination that could do harm to people, injure people, or even kill people. So what's to be done in that? We have this functional safety, and functional safety deals with keeping people from being injured by some faults occurring in electronics or in software. This is one part. The second part is now, if there are not real faults, let's say, for example, random faults or standard faults in software. So if there are not faults, but something happens in the cars due to the environment, due to something that happens out of the scope of the car itself. And due to this occurrence out of the car, could happen that an accident will be caused. So this is then called SOTIF. And the next thing is, we have this case of some accident happening caused by failures or caused by some misinterpretation by the sensors of the environment. Then this should all be covered by functional safety and SOTIF. But now there could be some people outside of this world acting on the whole system and bringing faults and failures into the system by intention. And this could be done by hardware, or it could be done by some other communication and bringing failures into this communication. And this is now a case of security.
Fascinating. So let me kind of like boil it down into so safety of intended functionality is beyond a regular failure, as you have said. So can you give us a use case for that?
So special case of functional safety is you have electronic units in cars. For example, today's simple passenger cars have around 100 electronic control units for several items, for several cases that are being controlled in cars. Let's say the ABS system or emergency brake assistant. And if a failure occurs in one of these systems and a hazard will occur, then we talk about functional safety. SOTIF now is you have no failure in the system, but outside in the environment. Let's say the classic case of you drive in a car in a narrow road, parking cars on each side, right and left. And of course there's the case, a child is trapping a ball running, crossing the track of your car. So what are you doing? Of course, just in front of the cars, running out of some parking cars, you of course brake. So imagine now the system that's been installed in a passenger car to protect this scenario. So take care of this scenario and even act faster than the driver. So we have lots of systems assisting you in the car as a driver. You know that already. Cameras are being installed in all modern cars to watch the track you are driving at. Then you have radar systems, for example the ACC, the adaptive cruise control, to keep distance, the distance of the car driving in front of you, to keep the distance equal the whole time. So you need cameras and radar systems to cover all weather scenarios. So if you take use of these cameras or radar systems or LiDAR systems, then some errors could occur. Of course, the errors could occur in the electronics and software in all these systems, but this is a matter of functional safety, of course. What is now SOTIF? So you have this child, the camera perceives this child, and if it sees the ball, and we have the algorithms in it that detect the child and the ball, then the system could bring the system to a halt. That means an emergency stop. What happens if this system perceives this child, but the child is not there? So this is, for example, called a false positive. So you have the hypothesis of the camera and of the algorithm. You detect a child and a ball, then there's the case, but there is none. And you have this emergency brake. And the driver doesn't even know what happens. So this is some error that could occur, but it is not caused by some elementary, for example, random or systematic fault. So systematic fault would mean that there is a software fault in the algorithm that detects something wrong. There is something in the perception. So you get a signal somehow, and you identify the signal as a child or as a ball. And yes, the child trapping this ball. So, and where does this error come from? This is not covered by a systematic analysis in functional safety. So this had to be extended in this new SOTIF standard.
Fascinating, Rolf. You mentioned about the scenario you mentioned somehow relates to autonomous vehicle. You know, when we will have level 4 cars or level 5 cars, obviously such scenarios will be more applicable. And my question to you now is, SOTIF in its current status, is it sufficient to cover safety of intended functionality of level 4, level 5, or is it still work in progress? And if so, what is the delta? How are we getting there?
Well, this standard, safety of the intended functionality, has been published in January 2019, this year, and it covers the first 2 levels of SAE 3016. It is level 1 and 2. And it does not say much about levels above that. So we have to improve that, or this has to be improved in the future.
Got it. So, level 1 and level 2, it doesn't go to level 3 or level 4, level 5. What do you think about level 3? Because that is sort of, so to say, the controversial level where there will be a mix of automated driving and a human driving. And from the avionic industry, we know that most of the fatality happens because of confusion between the pilot and the autopilot. What's your take on level 3? Is SOTIF going to cover level 3, or is it straight away going to go to level 4? Or what should it do?
Right, maybe we go a step back at the first line, because lots of discussions now are that maybe these 5 levels are too much. There is no doubt about defining level 0 or 1 and level 5. We have in level 0 full responsibility of the driver, and in level 5 full responsibility of the machine, of the algorithm. And all the levels in between are matter of discussion, because is it possible that we have a mixed driving status? This makes things very, very complicated. For example, in Japan, they simply use 3 levels. So there's the complete responsibility for driver, then the responsibility of the algorithm of the car itself, and there's only 1 level in between, an intermediate state. something maybe like this level 2 or 3 we have now on our roads. But this level 4 or this level 3 or 4 in between is somewhat a mixture of human that needs human machine interface, that's very, very complicated and has a lot of impact from either legal causes and ethics. So this makes things very complicated. Maybe there is a jump directly from 2 to 5 if possible, but this will be in the far future.
2 to 5, yeah, a jump from 2 to 5. That'll be fascinating. So you covered SOTIF so far. As far as I know, ISO SAE 21434, the other standard that you brought up for automotive cybersecurity, does not cover any scenario so far of autonomous vehicle. Can you tell us a little bit, I mean, maybe we, as you said, let's go one step back. Can you give us an overview first of this standard and how it's being developed? What is the status? And tell us how do you see the same implication of this standard on autonomous driving?
Well, I'm coming to automotive security soon, but I just want to add something about SOTIF. Mm-hmm. Well, I talked about this false positive. Mm. Of course, there's also false negatives. What is this? When we talk about that, there sometimes is confusion. Well, where does it come from? This is a statistical measure we talk about. And there is, of course, when you talk about false positive, we also have true positives. So my example with the child trapping this ball means if the child is really trapping the ball and we perceive this child trapping the ball, the system, let it be the driver or let it be the machine, the artificial intelligence or whoever will detect this scenario, will perceive it, and it has the hypothesis, yes, there is something happening. And if this hypothesis is true, we perceive this scenario and it really happens, then we have a true positive. The false negative will be, we have a hypothesis that is positive, we mean to perceive this child trapping the ball, but this scenario in reality doesn't happen. So it is a false positive. The hypothesis is positive. We think something is happening, but it doesn't happen. And this is called a type 1 error. And of course, then we have this false negative. It's a case, nothing is happening. We have the hypothesis. There is no child trapping the ball, and we perceive it as no child is trapping the ball, but there is also no child trapping the ball in reality. So it's a true negative. And then we have the fourth case of this false negative, and this is called the type 2 error, and it's really critical because we have the hypothesis, no child is trapping the ball. We think there's nothing happening, but in reality, there is a child trapping the ball. And this is a false negative.
Thank you, because I mean, there's this analogy from the machine learning community, like, you know, your spam folder giving you a false positive is better than their putting your important email in the spam folder, meaning that is false negative. Right. So type 2 is more severe than the type 1, you're saying. This makes total sense. So how does, since we are still in SOTIF, so let me out of curiosity ask you another question on that before we go to our cybersecurity topic, because that's going to be fascinating as well. How does SOTIF ask you to deal with such cases? What is the remedy SOTIF is prescribing?
Well, especially there are not specifically the architecture, but the testing. It focuses on testing. So you have to set up lots of scenarios and do testing about these cases. So the problem is you can't get all the cases in reality, and this is not possible. For example, this is one scenario I described with this child and the ball, but there could be several scenarios, such as a sunset, for example, sunrise or sunset, glazing, sunlight, getting the driver not realizing what the scenarios are, and of course these cameras and radars could also be tricked by some effects, shadows, not having the right light. There could be shadows perceived as a real object, and this trapping has to be managed by either the sensors and of course the algorithms behind that. Setting the objects, perceiving the objects, realizing what objects we have, and getting the right destination, getting the right setting between these objects.
We have a sensor fusion where you plausibilize different sensors, and based on the confidence value, you take the best one. But you're like you said, in SOTIF, the recommendation is you have to have a test vector. You have to cover, and right now, as you rightly mentioned, testing, everything is just not possible because there are infinitely many test cases, because it's just not finite. What do you think of simulation playing a role in this?
And this is exactly what I tried to mention. We have to make models and simulate all these models, and this is the only way we can manage all these scenarios. But even this could be not sufficient. So we have to there are millions of scenarios, and even if you have a table telling all the scenarios, you have all combinations of scenarios happening. They're not only scenarios, but also environmental situation. You have to take into account the sunshine, sunny weather, snowfall, fog, all kinds of environmental situation, and this makes the whole scenario even more complex. And you have to deal with all these scenarios. So you need a method to reduce these factors.
Fascinating. To put it as a segue to enter our automotive security discussion, even these environments that you mentioned, we're not even talking about scenarios where someone deliberately will try to feed false information into your system. And this is where cybersecurity comes. So tell us about it. Tell us about the status and how it developed in the last 1 year. Your take on it.
Okay. So right now we have this standard automotive security. In our last talk, we already mentioned this SAE J3061, which is not a standard yet, but just some sort of regulation. But you can get a red line walking according to that, just to insert cybersecurity into automotive business. This ISO 21434 will be set up to give real methodology to apply the cybersecurity on these scenarios. So, but this is due right now. I'm not directly in this commission, but it is due to be published end of 2020. And how is it set up? It is about designed, so the standard is about designed like the ISO 26262. There will be a management of cybersecurity, so we have to manage all this. Then we set up a concept phase. We need to make concept. concepts. How are you going to manage this cybersecurity, and how are we going to work together with functional safety and with the architecture itself? Then we have the product development that includes system, hardware, software, all the standard development. And as in ISO 26262, there will be a production unit, maintenance, which is apart from IEC 61508, a part that's been included in ISO 26262. And then, of course, we have these supporting processes, such as change management, configuration management, project management. These are crucial to manage functional safety, SOTIF, and cybersecurity.
Fascinating. So these things that you have mentioned, these activities, if we think in terms of the V model, there was rarely anything new, only the context have changed. Instead of functional safety, we want to consider also cybersecurity. This is how it sounds like.
Maybe we could add something again, because I have lots to talk. Maybe I could add this. I forgot the risk management, of course. This is very important.
Risk management is definitely.
Risk management, of course we need that too.
We need that too.
And the risk management in functional safety is dealt with by the HARA, it's hazard analysis and risk assessment. And a similar thing will be introduced in cybersecurity. This will be the TARA, the threat analysis and risk assessment.
And also in the V model, there is another analysis that ISO 21444 recommends. This is the vulnerability and risk analysis, where you have the architecture. From the architecture, you do a vulnerability analysis. When you're actually drawing the requirement, you think about the threats. Now that from the requirements you've derived the architecture, you have to do a vulnerability. And obviously we have the right side of the V model. And to me, it looks like, again, the standard is going toward, okay, the security, it does not prescribe any security mechanism, but it will require some test coverages. What do you think about that? So some security specific test coverages. What's your opinion on that?
Could be like that, because, for example, in the automotive security standard, they talk about the CAL, such as the ASIL.
Yes.
Well, this is what's the idea that we have in the automotive security. We will have some levels. So this is the cybersecurity assurance levels, they call it. Well, I don't have that much insight what it will work like, and the methods may not be clear right now, but it should happen like that. There should be some similar levels as the ASIL in cybersecurity. But there's a decisive difference between functional safety and cybersecurity. We are talking about probabilities in functional safety. And we have to reduce the risks, the probability for a risk for this hazard to below some extent. This has been done by functional safety since years, and we have scenarios and can get one scenario after the other and reduce this risk by time. And this can't be done in cybersecurity, because this attack or the attacker will search for the one hole he can get into. And if we reduce the probability to access some system, then they will specifically find this hole or try to find this small hole. So you can talk about probabilities such as we talk about in functional safety. So there needs to be some different mechanisms and methods.
Well, in J3061, they have put a number of methodologies. One of them were like a two-dimensional. One is the knowledge level an attacker would need, and another dimension is the economic incentive. And I'm not sure, probably even there were like in one dimension where you have the safety impact. I agree with you 100%. You cannot put a number, a probability, like the way you put in ISO 26262 in functional safety. However, we have to come up with some mechanism, because if we want to make our car 100% secured, it's just not going to happen. So
it will not be possible.
It's not be possible. It's just not going to be possible. So we have to come up with pragmatic solution, and this is what we are hoping that ISO 21434 is going to give us a guideline for that.
And probably there will not be any fixed measures or processes or methods. They may vary by time.
Right.
So you have to find new measures in future.
New measures in future
Yes.
is really the way to go.
And I guess this should be introduced in these standards.
Now, coming back to your master's program, because we promised in the beginning that we're going to talk about, we're going to revisit this topic. What are the things that you cover from the discussion today? Do you cover such things, really cutting edge technologies like emerging ones? Do you cover in your master's program? Tell us a little bit about your master's program.
Yeah. Well, the master's program or the master's course is called Advanced Driver Assistance Systems and should cover, of course, the levels from 0 to 5 that we had already mentioned. So from driving in a car, having the responsibility on the driver, up to full automated driving. So right now we're talking about highly automated driving or fully automated driving. And this is covered by this master course. And in all different kinds, we have subjects that deal with electrical mechanics, so sensors technology, microcomputers, the communication systems, but also the mechanical engineering. We have the vehicle itself, the mechanics of the vehicle. We have the testing systems with hill and sill testing stands and module testing stands. We also have the third subject, computer science, that deals with computer fusion, computer vision, and about all the algorithms in real time. So this has to be taught to the students to get a real background and a fundament to work in industry when they start working. So this is the background. Now, what is the SOTIF part of it? Do we cover that? Of course, I will tell them what SOTIF is, but there is a institute there we set up in Kempten, and we have the A-Drive Living Lab. It's a building that we try to work on like the V model. It's a V model in real, so students can work there doing projects and testing them immediately. And I especially want to announce Professor Bernhard Schick, who set up this A-Drive Living Lab. So the A-Drive stands for example, automated driving, autonomous driving, whatever you will call this A. And we have a special thing installed there that's fairly new, a simulator. So we're doing modular simulation there, but also the real simulators. So we put in a simulator with that could really simulate driving scenarios. You have a screen there, and we adopted a simulator from the company of AB Dynamics that installed this simulator already at Williams, the Formula One drivers, and they had a very dynamic simulator. You can find that on a video. I will give you that link.
The link will post also
Yes.
in the description. Yeah.
Just to find it.
Yeah.
And this simulator has been installed in Kempten, and last week it's been rather finished, and we do the first tests now. And I hope to do tests with SOTIF on that simulator too. That's what we plan.
Fascinating. Do you also do some hackathons, try to do cybersecurity hacking simulations in that environment?
Well, this is of course not possible right now, but this can be planned, and I hope to work together with you then.
Right now in the industry, what are the biggest challenges you see in terms of safety and security? Because we're at the dawn of an era that automotive industry is about to change massively. Are we a bit too early, too optimistic about autonomous vehicle? Is it safe enough? Do we have enough data to really say, okay, we can go to level 4, level 5, anything beyond level 2? I mean, are we ready? Are we ready in terms of safety? Are we ready in terms of security? And what are the biggest challenges in your opinion?
Well, right now we are on the way from level 2 to level 3. And the automotive industry is of course forcing this way to help people and of course to reduce the accidents on the road. We're talking about 3,600 fatal accidents in Germany per year. And this is only in Germany. So we have the idea that with the driver assistance systems, we could reduce this just to help the drivers. But right now, we don't have the feeling of the people that they would give away the responsibility to the car because we have no trust in that. There were many surveys done by Professor Schick and his members on human factors, for example, studying this driver assistance systems, for example, the lane keep assist system that's been introduced in the cars since a few years. But these have to be optimized a lot to get a positive effect on the trustfulness of the drivers. Trustfulness. This is a very critical word because drivers will only make use of these assistance systems if they have trust in them. And if these systems have, for example, these false positives, false negatives, there will not be any trust in it and it will not use them. And a scenario for level 5 means we must have full trust in these systems to apply the systems. And we need a lot more of assistance systems to get up to level 5. And not until this will happen, to gain the trustfulness in these systems, we will not be able to access level 5 yet.
Fascinating, Rolf. So my final question is, what are the hopes you have in order to get there? Are we in the right track? Do you think we will be? What's your timeline? Do you think it's going to be 10 years? It's going to be 5 years, or is it going to be end of this year?
Well, it depends on what the aim is.
Yeah.
What the goal is, where we're heading at. Well, of course, there are goals in a reach of 5 years, but if we're talking about level 5, it will rather be around the year 2050, I guess, in normal passenger cars. And we already talked about the last times that, of course, level 5 is possible in limited regions. If we talk about highway, it is already existing, of course.
In the US, there is a level 5 pods which taking senior citizen from point A to point B.
Right.
In a very limited environment, level 5 is already possible today.
This is no problem, but not in generic traffic.
This is really important. When we say autonomous vehicle, it's really important to agree on a definition, because a lot of people understand a lot of things, from taxis to whatnot is being understood by people. We have seen pictures, a dog in the steering seat. So I think it's very important to create public awareness and let them understand what autonomous driving is. What do you think of that?
No, that's completely right. I agree. Yeah, because people have to accept that, and you know what's happening in Japan? They have the elder people that you have to take care about them, and you need some robots to take care about them, and they have to be sensible for them. So you have to know how to work with them and deal with them and have the senses with it. So the emotions are a big case, yeah.
Right, right. Even if we will eliminate the driver, the human driver part, but in the end, the autonomous vehicle will take people from point A to point B. So it will be, I mean, you cannot eliminate the human factor fully. End of the day, we'll have to incorporate that. So Rolf, it was really a pleasure having you again. I'm looking forward to have you in many more episodes here. Thank you so much for joining us, and yeah.
Thank you for being here, Hasan. That's nice.
So thank you so much for watching. This was Professor Rolf Jung from University of Kempten. If you have any question, comment, please feel free to write. And if you have liked it, please hit the like button, subscribe to our channel. Your support means a lot to us. Thank you so much for watching. This was Hasan Akram from Matrix Tech Talk. In this podcast show, we bring in the industry leaders and experts in the automotive domain to share their experiences along their journey. The mission of our podcast is to start a dialogue that will allow us to understand the development of automotive industry and where the automotive industry is going. You can ask questions to our guests directly. Just send us an email to podcast@matrix.de. We'll schedule a call with you during the recording and you'll be part of our show. Make sure you subscribe so that you don't miss any new episodes. Please share this video to help others get enlightened as well, and that would mean a great deal to us. See you in the next episode.